Hi, my name is Christopher, and my project is on 3D printing filaments leaching into water. We are using 3D printed parts near water more and more often, and they might damage our drinking water. Are 3D printing materials such as PLA, PETG, and ABS susceptible to leaching into water over a period of time? I hypothesized that ABS would leach into the water the most, then PLA, then PETG, and then PLA. I also hypothesized that the PLA would receive more damage to the part than PETG and then ABS. This is because ABS is generally more a toxic filament, however, it's extremely strong. We are heading to a future where we use 3D printers for almost anything. However, as we move toward that goal, we need to make sure we are keeping ourselves safe and environmentally friendly. Recently, many organizations have been using 3D printed objects to hold, transport, and even clean drinking water. This is a problem because filaments like ABS, PLA, and PETG might leach into the water supply and cause harm to humans and the environment. To lower the negative effects on society, I will determine which plastic leaches the least so we can use that knowledge to better the world. My procedure was printing 45 containers of 15 of each PLA, ABS, and PETG. These containers I CAD'd on Tinkercad and then downloaded onto Prusa Slicer and sent to myVoron 2.4 to print. As soon as the print finishes, I put it into a plastic bag and I labeled that bag with a Sharpie on the outside of the bag. And after I was done with all of the prints, I looked at each print's layering to see if there was anything wrong with the print to start out with, and there was nothing that would have affected the print that I got notice of. Then I took the pH level of, I took the 1 in 15 water quality test strip of my water at home from the faucet. Then I put water into each 3 of each day, which was day 1, day 7, day 14, 3 of each of those, and 3 of those because I did 3 of each for each type of filament. Then I put vinegar into I put 3 vinegar in I put vinegar into 3 of each of those also, but there was only one day. I put bleach into 3 of each for 14 days. Then I checked the number of plastic particles in each container using a microscope. I checked the 1 in 15 water quality test on days 1, 7, and 14. And once I did that and all the water was out of the container, I checked for damage on those days. And when checking the particles in each container, I poured the water into a filter with a Buchner funnel. So I had the filter paper and then the Buchner funnel inside. The filter paper was inside the Buchner funnel, and then the Buchner funnel was going into an Erlenmeyer flask to catch the water. And once all the water was down there, I took the pH level and assessed for damage. While doing all of the above, I recorded that into an Excel file, and finally I'm evaluating the data and proclaiming the safest and strongest filament of the 3. So some of my key observations was that there was little to no damage on the majority of the prints. On 4 occasions, however, I saw that the water had warped the plastic and it was kind of like wavy. So if this is the layer of plastic sitting like this. It was kind of going up and down like that. And yeah, and then the parts containing bleach, I noticed that they didn't turn white and they weren't bleached. However, the smaller particles that came off of the part were bleached, which seemed weird to me. And then all of the data was too inconsistent or too similar to each self, except for the bleach data, so I couldn't analyze the other data correctly. Well, I could analyze it correctly, I could not analyze it in a way that was fair to the tests. And then the total particle count for the bleach was 130 PLA, 91 PETG, and 53 particles of ABS, which was completely the opposite of the predictions I had for this test. So the day 1 water test had 0 PLA particles, 5 PETG particles, and 4 ABS particles, which shows that PLA had the least particles to start out with in the water. For day 7, it was 12, 16, and 13, and because those are too close together, and the, let me just show you. Because they were, here it is, because they're too close together and their standard deviations are almost the size of the whole entire thing, there was too much variance in each category, and they were too similar across to make a fair judgment on that. And same for the day 14 water with 17 PLA, 20 PETG, and 18 ABS. However, like I said, day 14 bleach was completely opposite with 130 PLA, 91 PETG, and 53 ABS, which shows that PLA had double the number of particles that ABS had, and 50% more particles than PETG. It's right here. And yep. And for vinegar, it's around the same thing here. Vinegar was 9 PLA, 10 PETG, 9 ABS. However, there was almost no variance at all, so I could not draw conclusions except for the fact that there was no variance. And then the vinegar had 50 more nitrate parts and 10 more nitrite parts for all 3 of the vinegar tests. And the bleach, however, it had crazy amounts of lead and iron in it. So I concluded that the test was not functioning because there is no possible way for there to be no lead in the first tests at all, and no iron in the first tests, and then suddenly iron and lead appear out of nowhere. So, and in conclusion, why is it doing this? Here. In conclusion, there, over a 2-week span, there isn't a lot of a difference. There may be a little of a difference. However, over a longer span of time or having bleach added to it, which happens a lot because you clean your pipes with bleach and you also some people clean water with bleach. And so if bleach or more time was added, it will end up like the bleach results with PLA having way more than ABS. Way more particles than ABS, and then PETG being right in between the two. And for the damage, there was two PLA had waves, one PETG had waves, and one ABS that one of the bleach ABS had waves, and the other three were all water. So I said that ABS had the least amount of damages, but it wasn't very much different than the others. So very little variance here in all of this. So I concluded that ABS is the safest to store your water in without getting plastic particles in the ABS. However, that does not mean it's safe in other categories, like a lot of other bad categories. Why did I say that? That does not mean it's the safest in all other categories, like having fumes come off the printer. Those are horrible for you, and many other things like that. ABS isn't a nice filament to deal with. In recent years, 3D printing has exploded, which in turn turned up the usage of 3D printed items in water. I made a 7.5 to I'm going to cut that out. So cut. I'm going to wait for 10 seconds and end it after I explain this. So this is my picture of the bleach slide. This is the whole entire filter. I can show you a filter right here. It's a 56 millimeter filter. It's an empty filter. So you can't see any of the black dots on there because all of them were bleached. That one dot right there is just a speck of dirt or dust when I was transporting it. Have to move it a couple of feet. This is the PETG water days, PLA water days, ABS water days, all of them together. The day 14s and all of the particles for all the days. This is my chart that I use to write down the 1 in 15 water tests, drinking water tests, as you can see. And guess thank you for listening to my project. Have a nice day.